Thank you for coming back for this week's lesson. This is week 3 of PRG 102. Tonight and throughout this week, you'll be going through loops and arrays, which are very interesting topics. I have 2 videos I want to show you guys tonight that will quantify or show you a little bit more other than just me lecturing on arrays and loops, and we can talk about them after we go through them. And then afterwards, we're going to go through our assignment and our assessment, just like we have for the past 2 weeks. Again, before we go into those, my information, I posted it for the past 2 weeks. Again, if you have any questions or concerns, please feel free to email me, give me a call, or shoot me a message on Skype. I'll respond just as quick as I can. Also, I didn't put on here, and a lot of you have been responding through Canvas, and that's perfectly fine. I see those messages also, and I respond to those as best I can. I will say, though, that if you send me a message in Canvas, it takes me a little bit longer to get to those messages simply because they don't show up on my cell phone as quick as the notifications would for an email or a text message. So I will see them and I will respond to them as soon as I get them. But an email and a text or an email and a phone call will be a whole lot faster. Again, I have graded all of the assignments, the assessments, and the discussions for the past 2 weeks, for weeks 1 and 2. So if you see any issues or discrepancies, please shoot me an email or give me a phone call just to let me know. James, you're asking, so use direct email for a faster reply. Most likely, because it does come straight to my cell phone, which, just like everybody today, I do have it on my hip at all times. All right, so before we get started, does anyone have any questions, James or Aaron? Okay, so I'm going to go ahead and pop up the first video. The first one is on loops, which are, just to give you a little brief overview, there are 3 different types of loops that you'll hear about when he's talking about them. One is a for loop, one is a do while loop, and one is a while do. The difference is, just like in your readings over this week, you'll find out that a for loop is counter controlled, and a while loop, you'll hear something called a sentinel, which is sentinel controlled, meaning it's waiting on a condition to be true before it exits out, or a condition to be false before it exits out. So those are the 2 major differences between a for loop and a while loop. And the good thing about loops and arrays, just like our decision structures for if statements, it's all universal. So everything that we've gone through over the past 2 weeks, and even for this week and next, it can be ported or used throughout any language. So it can be C++, it can be Java, PHP, any sort of language that is not scripting. And what I mean by a scripting language is HTML4, HTML5. Those are scripting style languages. All right, so let's go ahead and pop this up.
Hello, everybody. So welcome to this episode of Programming and Algorithms. Last time we were looking at the while loop, so this time we're going to look at other forms of loops that are provided by many number of programming languages. They all do the same thing, they all allow you to iterate over and over again, but different loops are suitable for different situations. The for loop does exactly the same thing as the while loop, except it's much handier if you're doing a countdown or count up. So let's say we're counting from 0 to n-1 or n-1 to 0. A for loop does it slightly easier. If we look at an example of a while loop to print out the numbers 1 to 5, we'll start off by assigning a to 1, then we'll say while a is not equal to 6, print out a, and then add 1 onto a. So we iterate through and we get our answer. The for loop does the exact same thing as this, but the way we express it in pseudocode is more compact. So we declare the a within the for statement and we declare the range of it. So we say for a in 1 to 5, do print a. So the for loop says declare an integer type called a, start counting at 1, increment by 1 each time, 1, 2, 3, 4, 5, and stop at 5. It's a very compact way of expressing the same thing as if we go back again. The declaration is done in it, the condition is done in it, and the increment bit is done in it, all by just saying for some value in a range, the range here being 1 to 5, do print out an end for then at the end. So lots and lots of programming language to implement that, and it's a nice way when you're counting up and down, or we'll see later accessing elements in an array and things like that. So the general is for some value in a range, do a series of statements. The next type of loop we're going to look at is called the do loop. It's not implemented in all programming languages, but many of them use it. It's the exact same thing as a while loop, except a while loop can be run 0 or any number of times, whereas a do loop is run at least once. So let's say we have a menu program that we know we'll have to print out the menu at least once. We say do, print out the menu options 1, 2, 3, and 9 to exit. And then we'll get whatever value the user puts in, and if they select 1, we'll run some function to input data. If they select 2, we'll delete the data. Select 3, we'll print the report. But if they select 9, we exit the menu. So because we have to print out this menu at least once, we'll keep printing out this menu until they select 9, and while value not equal to 9, if they select 9, then we exit the loop. We can see it's exactly the same as the while loop, except the condition is moved to the end instead of the start. So it happens to happen at least once. As I said, for menu options, sometimes it's clearer when you're reading somebody else's code to do it. Not all programming languages have the do loop, some do and some don't. But if you're in one, you know it's going to be a menu or something like that. Its general form is do some statements while some condition is still true. And there we go. And when the condition is false, it exits the loop. Our final one, and is less frequently than either the do or for in programming languages, the languages developed by Niklaus Wirth, Pascal, Modulo 2 and Modulo 3, for example, have this loop, which is like a while loop, except it has no condition. It's an infinite loop. It keeps on going. We don't necessarily think that's a great idea, but there are certain circumstances where it might be useful to have a kind of infinite loop. And then it does have a command called exit that allows you to break out of the loop if needed. So if we were to implement printing 1 to 5 as a loop, we'd have loop, print a, if a equals 5, then exit. Otherwise, add 1 onto a. So a would be 1, we'd print it out. We check it, if a is 6, it's not. So we'd add 1, it's 2. We print out 2, then 3, then 4, then 5. When a is 5, we print out 5. Then is it equal to 6? No, it's not. We don't exit. Add 1 on at 6. We go back. Then exit on 6. So that's a loop. Strictly how we define an algorithm is a program that terminates, and in Alan Turing's 1936 paper on the halting problem, he makes this point. It's not really an algorithm unless it terminates. So we have to ensure, if we're designing code like this, that A will at some point get the value 6 and exit, otherwise there'll be a problem that it'll be an infinite loop, which we don't want. We don't want the loops to go on forever. We want the programs to finish at some stage. So our general statement, I guess, is if, do some statements, loop rather, do some statements, if some condition, then exit, end if, do more statements, then end loop. So that's 3 kinds of loops. We'll see you on the next episode. Thanks very much.
Okay, so that gives you a very brief rundown of what loops are. And he did talk about the multiple types of loops. He mentioned a for loop, he mentioned a while loop, and a do while loop. Did James or Aaron, did either one of you understand, or did you understand the difference between the do while and the while loop? So the difference, right. So the biggest difference between a while loop and a do while loop. Let me pull up this really quickly. Go into a language, it doesn't matter which one. Let's just do this one. So a while loop, basically we set our variable. So we say start program, stop program. In between those, what we do is we say int, which is a number, my number equals 5. Then we say there's 2 different types of loops that we're going to talk about. Let's talk about a while loop first. A while loop says while my number is less than 100, or a set defined number, we want it to loop. And in here we can say print my number and increment my number equals my number, if I can type, plus 1. So what would that actually be doing? If I said start, initialize my number, and I say while my number is less than 100, print my number, and then take my number and add each one. Right, James? It does. It adds 1 to it each time. Then it continuously loops until it hits 100, and then it exits. Right. So that is a while loop. A do while loop basically is start and stop. We can say int my number equals 5, do print my number, same thing we're doing earlier, equals my number plus 1, and it says while my number is less than 100. So James, you say it does something while the loop is running. So a do is the opposite of a while. So let me explain that. A while loop, you remember I said a moment ago before we started watching that video, was it had a sentinel condition that it checks for each time. It checks my number to see if it's less than 100. If it is, it ends. 100 is the case, right? It's the sentinel value that we're looking for. So a while loop effectively checks the condition and then it prints the information or does the loop. A do while does whatever it needs to first, right error without caring, and then checks the condition and comes up. Does that make sense? Correct, James. It does check after the loop is done. Well, after the iteration, after it iterates one time, it checks, and then it checks again on the second iteration and the third iteration until it reaches the desired value. That's how that loop goes. Then you have your third style loop, which is called a for loop. And for loops are very easy to work with. You'll see these in a lot more code than you probably would a while or a do while loop. It's just start, stop, int my number again equal to 5, for my number less than 100, loop, print my number. The difference in a for loop that you'll see in C++ or Java or Visual Basics or any high-level programming language is you will usually see it written like this. Int for loop for value where, actually let's take this away, my fault, for value being the number we're using. Actually, we can use my number, that's fine. And then you'll say my number plus plus. All three of these do the exact same thing, just a little bit different coding style. What the for loop is actually saying is I'm initializing my variable in the for loop. I'm actually going to set it equal to 5 automatically. So when my number is less than 100, it will exit. Does the Java print each loop also? You're asking what the actual print command is in Java? No, it's actually system.out.println. My number. And this portion right here, the my number plus plus, essentially means the exact same thing as my number equals my number plus 1. That's just an easier way to write it, or a faster way to write it. I could just as easily have written it that way. And it does the exact same thing. Any questions on loops so far? All right, so the last thing I want to talk about with loops before we go into arrays is loops are all nice. Nice one, James. Which kind of plays right into my next statement. While loops, for loops, loops in general, to iterate through a list of values or to move through a list of values is a great tool. It's a wonderful tool to have in your arsenal. But if you're looping through something, you might want to have a reasonable expectation that you're also going to be doing some sort of decision-making process. For instance, let's take a look at the while loop here. We can say if, using a decision structure, if my number is less than 10, then print low number. You can then say else if my number is greater than 10 and less than 50, then print approaching maximum. And then else, using the else decision statement, we can say print getting too close. So that's a decision statement or a decision structure inside of a loop. So if my number is 70, what do you think it would print? Getting too close. You're absolutely right, Aaron and James. All right, so that's how you add decision structures or decision statements inside of a while loop. You can also do this exact same thing inside of a do while or inside of a for loop. Aaron, you said you're seeing it as a temperature reading for GPU. That's not a bad thing. In fact, the way assembly language or the way low-level machine language works is it works in a continuous loop. It loops at so many iterations per second, or we call them clock cycles. So every clock cycle can do something, just like your central processing unit. Yeah, you would be about right. 60 seconds or 60 clock cycles per second, which would give you the amount of time it takes to process something. And all it's doing is cycling through over and over and over, waiting for a command to come through. And when a command comes through, it processes it and then continues. You would be correct on that, Aaron. All right, so let's go ahead. I'm going to show the next video. It's a little bit longer. It's about 15 minutes, but it gives you a lot more insight into arrays and how they work.
Hello everybody and welcome to this episode of Programming and Algorithms. In this episode we're going to look at a new special kind of variable called an array. And it's the first complex data structure we look at. The variables up till now have been simple structures like a boolean, an integer, a single value of those, whereas an array is a collection of those values. So imagine if we had to record the age of everybody in the class. We could do that by declaring a variable for each person. So it would be integer age 1, integer age 2, integer age 3, all the way down. So if we had 25 students in the class, we'd have to declare 25 variables. If we had 40 students in the class, we'd have to declare 40 variables. If we had, as with my first year class, one of the other classes I teach, I have 108 students. So we'd have to declare 108 variables. Which is, it's just not pretty to see that in a program. There's just so much unnecessary code, whereas we have a special kind of variable that allows us to declare an array of the same type of variable, and we call it an array. So it makes things nice and simple. So if we declare an integer of type, the type is integer, and it's a collection of 40 integers, and the overall name of that integer is variable collection is age. So what we're saying is, give me space for 40 integers and use the handle age to refer to them. So we've created 40 boxes essentially. The overall collection of boxes is called age, and the only kind of values we can put into it are integer types. Interestingly enough, and this is common to some programming languages but not to others, when we number an array of 40 elements, we number the boxes 0 to 39. I would see this very much like UK hotels. In the UK, if I have an 8-story hotel, I've got ground floor, first floor, second floor, third floor, fourth floor, fifth floor, sixth floor, and seventh floor. So if you have 8 stories, there's 7 floors on a ground floor. And the same thing with an array. You go from 0 to 39 if you've got 40 elements. You go from 0 to 99 if you've got 100 elements. You go from 0 to 999 if you've got 1,000 elements. So we start at 0 and work our way up to 39. It's just one of those things. In some programming languages they do it, in others they don't. They start at 1 and go up to 40, but in many they start at 0 and work their way up to 39, or the size minus 1. So if the size is 40, we go from 0 to array size minus 1. So let's look at the array with values in it, because the numbers we're looking at are just the addresses of the elements of the array, but the values in it are something else. So let's say we've got the ages of some of the students. The first student who's referred to as age 0 is 44. The second student in the class, age 1, is 23. The third student in the class, age 2, is 42, and so on. The sixth student in the class, age 5, we don't know their age yet, so we've left that as being blank. And between numbers 7 and 38, we've done ... there to indicate there's values in there as well. If I say print out the value of the first person's age, that is address 0 in the array, I get 44. So if I print out the variable value of the first element, numbered 0, we get 44. If I print out the third element of the array, which is numbered 2, we get 42. And if I print out the last element of the array, which is the number 39 is the 40th element, we get 82. If I try and print out the 41st element of the array, which is age 40, I should get an error in my code, and it should say it's out of the bounds of the array. So the bounds of the array is 0 to 39. So if I try and print out 40, 41, 42 or anything like that, it'll hopefully give us an error. Some programming languages are less good about checking the bounds of arrays, and that's how a lot of hackers break into systems, by reading values out of the scope of the array. But most good modern programming languages will check to ensure that you're only reading values within the scope of the array. So if I declare a variable array integers 0 to 49, that means I should only look at the 50 elements of the array. Let's say we found out that the 6th student who's age 5, let's say we found out that their age was 54, then we could all we need to do to assign that element of the array its value, we just assign it typically the same way we assign any variable. We just say 6th element is age 5, gets the value or is assigned 54, and then that will be filled in the blank space, just like that. Perfect. I like to think of the elements of the array as being like slots in a pigeonhole, files in a filing cabinet, or locations in memory, even more boring. If we look at our array again, and let's say we wanted to add 1 to each value in the array, we'd get those values if we wanted to add 1 on. If we did that, how we could do it, coding-wise, is to say age 0 gets the value age 0 plus 1, age 1 gets the value age 1 plus 1, age 2 gets age 2 plus 1, age 3 gets age 3 plus 1. That's very slow and tedious, and if we've a 100 element array or 10,000 element array, that would take a lot to do. Whereas we do have a construct that allows us to add 1 to a value and keep going around and adding 1 to a value, going from 0 to 39. Can you think what that is? If you think it's a loop, you're quite correct. So we could do that using a loop. So we could declare a counter n, start at 0, and keep on going until n reaches 40. When it reaches 40, it'll stop, so it'll just do 0 to 39. And we do age n gets the value age n plus 1. So it'll be age 0 gets the value age 0 plus 1, age 1 gets the value age 1 plus 1, age 2 gets the value age 2 plus 1, etc. And then we add 1 onto n each time around the loop. We said it before and we'll say it again as well. We can do that also using a for loop, a slightly reduced way. All we need to do is say for n in the range, for n in 0 to 39, do age n gets the value age n plus 1. So what does that do? That says when n is 0, age 0 gets age 0 plus 1. When n is 1, age 1 gets age 1 plus 1, etc., etc., up to 39, and then it stops. So when we're manipulating arrays, loops, and particularly for loops, are a very effective way of traversing or going through each element of the array. If we wanted to add up the ages of everybody in the class, how we do it is as follows. We just say the total of the array is, we'd have a running variable called total, and we'd go from, again, each element of the array using the for loop into 0 to 39, and then we'd say total gets the value of total plus the current value. Total starts off as 0, then age 0 is added onto it the next time around, age 1 is added onto that, age 2 is added onto that, age 3 is added onto that, age 4 is added onto that, age 5 is added onto that. So the running total keeps adding on each value onto it until you get to the 39th element, and the 39th element is added. Then we've got the total of all the people in the array, their total age. So if we want to calculate the average age, all we'd say is the average is, same thing, we do the running total, we go 0, start with the total, add all the ages up. Then how do we get the average? Well, if we're talking about a simple mean, a simple arithmetic mean, we're just saying divide that total by the number of people in the class. If there's 40 people in the class, let's divide the total by 40, and then we'll get the average age of all the students. At this point, I think I'll talk about using variables in a constructive and progressive way, and trying to avoid hard coding stuff. When we have print total divided by 40, what we have done is hard coded the size of the array to be 40 right there. So we've said the value is 40 there. If we change the array to 70, we have to change 2 places in the code. We have to change the for loop for being in 0 to 39 to 0 to 69, and we have to change total to be total divided by 70 now. If we change the length of the array to 100, we have to change it for in 0 to 99, and then print total divided by 100. So if we change the size of the array, there's a couple of different values that need to be changed. So we can use a variable to reduce the amount of changes being required. So we declare a variable and we call it the size of the array size, and we say it's 40, then we don't need to divide the total by 40 at all. We can just divide total by array size, which is 40. And we can also get rid of the 39 and say it's array size minus 1, so because 40 minus 1 is 39. Then what we've got is a very flexible approach to the array. If we change the array to 100, we just change the variable called array size to 100, and then the for loop will be 0 to 99, and we'll be printing the total of total divided by 100. So we like using variables like that. It's almost in driving, like defensive driving. Anytime we hard code a value in, we end up with problems like the Y2K problem, where in the year 2000 there was a lot of problems because certain year values were hard coded in. So we try and avoid hard coding of things like the size of the array, or I don't know, the compound interest rate we're paying. So if our compound interest rate is 15%, instead of multiplying everything by 15 over 100, let's save a variable called interest rate as 15 over 100, and then everywhere else in the code, just whatever that variable name is, use that in the code. And then if we change the interest rate, we just change the value in one place. With an example like this, where there's only 2 places we're using the array size in, it's not as significant. But when we're looking at tens of thousands of lines of code, it is very important that we use variables to avoid hard coding values as much as possible. We can also have an array of real numbers. So if we were looking at people's bank balances, for example, the first customer has €22 on their account, the second customer has €65.50, the third has minus €2.20, so they're in debt, the third has €78.70, the fourth has, the fifth customer along rather has €58.54, the sixth customer along is in debt as well, the seventh customer has 0 in their balance, and the eighth customer has $47.65. So if the bank asked me, can you write a program to tell me who's in debt? By inspection, we can tell the third customer along and the sixth customer along, customer numbers 2 and 5 are the ones in debt. But if we have 100,000 customers, we're not going to do it by inspection. So we're going to write a little bit of code, and it's a for loop again. It's go through the whole loop, check that the current bank balance is, check if 0 is bigger than the current bank balance, and if the current customer's bank balance is less than 0, just print out a message saying that that user is in debt. Now in reality, we won't just print out a message saying that user is in debt. We'll probably print out a report page for each customer saying this is the customer, this is their balance, maybe this is their credit limit and things like that. But in our case, if we go back to the list, we see it's customers number 2 and 5. So when we run this program, it will just print out user 2 is in debt, user 5 is in debt. So it'll print out the message, because we're in a loop, for each customer whose balance is less than 0. We can also have an array of characters. So if we're, I don't know, doing a gene sequencing thing, and we've got the 4 genome types A, C, G, and T, and we've stored an array of 40 characters, and we just want to look at how many G's are in the gene string or gene array. All we do is start from the start of the array, go to the end of the array. If the current element is of gene type G, then add 1 onto the count. So we start off, set the G count to be 0, and keep adding 1. And then once we finish the loop, just print out that the total G count is whatever G count is. We could do the same for an A count. We can also, as well as having an array of characters, we can have an array of strings. So we could have words, an array of words, for example. We could have an array of pets. So person number 1 has a pet of a dog, person number 2 has a pet of a cat, person number 3 has a pet of a dog, person number 4 a bird, person number 5 a fish, person number 6 a fish, person number 7 a cat, and person number 8 is a cat as well. So we could ask how many people have dogs, how many people have fish, how many people have birds, things like that in the same way. And we just do a loop for n equals 0 to 7. If pets, open square bracket, n equals cat, then add 1 to cat count, same as we've done for the characters. And finally, we can have an array of Boolean. So we'll remember a Boolean is a special type that only has one of 2 values, true or false. And it could be something like, are you, I don't know, coming into college or something like that. If you're coming, student number 0 is coming into college, student number 1 is coming into college, student number 2 is not coming into college, student number 3 is coming in, 4 isn't, 5 is, 6 isn't, and 7 isn't. So we could record whether they are or aren't coming into college or something like that. That's an array of Boolean. So same as the variable types, we can have an array of integers, reals, characters, strings, and Booleans. So that's it for this episode. Thanks very much. We'll see you on the next one.
Okay, so yeah, he does jump around a lot, but he does have a lot of good information. The first part that I want to touch on is he mentioned a bunch of different types of arrays that we can work with. And the different types that he mentioned are Boolean, string, integer, and character. Each one of them has their own separate type of arrays that you can work with. Take, for instance, Boolean. With a Boolean value, you can only have true or false. That's all you can have. So if I had a Boolean value of B, and I was going to have 4 different pieces in the array, well, setting that up, 0, 1, 2, 3, and 4, I can say true, false, false, true, true. See how that works? Does that make sense? Each one of the pieces in the array, this is an array of 5, starting from 0 going to 4. Now, he mentioned also that some programming languages use 0 to start with, others start with 1. That is the case, to be honest. But in the essence of transparency, I will tell you that most programmers that are in the field working today will always start with 0, no matter what you're talking about, because we all have that mentality of 0 to 9, not 1 to 10. It's the same thing. It's just right, James. It's like the ground floor in Europe, like you mentioned. Starts at the main floor and works its way up to 9, or to its number. Okay, so he mentioned strings and integers also. String array, I can have a string array, just like you mentioned, of animals. So I can do a string of animals. And I'm going to have just a couple. So 0, 1, and 2. For those, I can have a fish, a cat, and a dog. I said 2, didn't I? It's actually 3. You're right. So an array of integers, let's go here. So string animals 3. No, it would be 2. You start at 0 and work your way to 2, just like you start at 4, 0, 1, 2, 3, 4. Yes, but 0 plus 3. In IT speak, 0 plus 3 is actually equal to 4. I was waiting on this to load in the background so I could show you. So let's go ahead. I'm going to show you a little bit when it comes to working with Java and arrays and loops. Loops and arrays. Okay. That's okay. Don't worry about it. So we're going to start off. I'm going to show you a basic for loop. So we're going to say for I equals 0, I less than or equal to 100, I plus plus. System dot out dot line I. So if I save this and I run it, this is a basic for loop. You'll see my number starts at 0, just like it says here, and it counts 1 each time, all the way down to 99. You see how that works? I can do while I less than 100. The plus plus is the switch, James. It's basically saying add 1 to it. So to start with, for a for loop, I didn't have to specify anything. But to start with a while loop, I actually do. So let's say for loop number and then say while loop number. That way it breaks it up a little bit. And we're going to run that. You see what happened? It never actually changes. It's still 0 for that while loop. I'm going to stop it. That's what he mentioned a little while ago in his video when he was talking about an infinite loop where you never actually change the size, where you never iterate. So what I would have to do is I would have to say I plus plus to run that. Or like we said earlier, I equals I plus 1. Same thing. It's just how you want to write it. So here we go. We have 0 in the for loop, all the way down to 99. And then we start with our while loop, starting at 0, all the way down to 99. Yes, I is the integer. INT stands for integer. INT stands for integer. And then we can reverse this and say do while I is less than 100. Just to make this look a little bit easier, I'm going to remove this one. James, you make a valid point. You're asking, so will it stop at 100? Let's check and see. Started at 0 and worked its way all the way down to 99. So it also does 99. The difference is where we put our condition statement. That's the only difference, is where the condition statement is. Well, yeah, if I did this instead, Jim, it'll actually print out 100. It does actually increment it by 1, but it never prints it out again. So those are basic while loops and basic for loops. Again, going back to our previous one, looking at, let's go back to our while loop. Let's do our first while loop. We're going to remove our for loop. We're going to say, let's make a decision structure. So if I is less than 10, else James, you're asking if this is using Eclipse. Yeah, I am using Eclipse. After. So 0 to 9 in the decision statement, it prints before. in the decision statement after it changes. See how that works? Yep. Okay. So those are basic loops. And to show you arrays in this, I can show you if you want, but it'll be a little bit more complex to work with. All right. I'm going to show you a string array. Just to start with, we're going to say string array, and it's going to be of animals. Equals, and we're going to say cat, dog, fish, dog, cat, cat. How big is that array? Let me ask you that question. It would be 6. You're right, James. So 0, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. The good thing about most high-level programming languages, I'll show you. You can do animals dot length, and it will tell you how big it is. We can then add in our array or our for statement. We can say for string animal in animals. I want you to print out particular animal. And if you're not following, please let me know, because I don't want to keep going if you're not following it. So you'll notice it goes cat, dog, fish, dog, cat, cat. What we have to add in order for that to actually go to a new line is a carriage return. You're familiar with hitting the enter key on a keyboard, or if you're like I am, which has been a long time ago, using an old typewriter, get a hard return where you actually take the physical spindle and push it all the way back to the left. We call that a carriage return or a new line return. That's what a forward or \n actually means. It's sending it backwards to the new line. Correct. It's new line. It stands for new line. So that's a basic array. You can do an array of int we can do an array of characters, or we could do an array of Boolean. All four of those work. Can it count the different animals? Yeah, yes, it can. So we can say oh, you still there? I'm good. Sorry. You have to do animals. Dot. Length. Bear with me. It's been a little bit. Yeah, this is not something I'm prepared for, but it's okay. Where is it? All right, so we can't do it with string. That's okay. Tell you what, I'll work on this and I'll post it back for you guys later on. I'll do a small short video of it and show you guys how to do it. Yep. All right, so that's okay. So yes, James, you can, and I'll show you how to do that later on. Okay, we need to move on to the assignment and the assessment. Okay, so looking at this week's assignment, it's chapters 5 and 6 on page 222. And it's all of the first one. And then in chapter 6, on page 267, it is just A. So let's go over the first one. So what would the output What is the output by each of the pseudocode segments in figure 525, which is right here? For A being 1, B being 2, and C being 5, while A is less than C, A equals A plus 1, B equals B plus C. Then it wants to output all that information. Are you sure? Let's take a look at it and let's see what it actually does. You're close. Well, give me one second. We're going to write this in Java and see what it looks like. So, give me a moment to set it up. It's 1 equals 2. I'll show it to you in just a second. Equals 5. While A is less than C. A equals A plus 1. B equals B plus C. And then out at print line, A B, I'm printing them out now, give me 1 second. And C. All right, so here's what it would look like. It would be, we start our first 3 variables. We say while A is less than C, A equals A plus 1, and B equals B plus C. And at the very end of that, we're going to print everything out. So it would actually be 5, 22, 5. All right, so the first A, number 1A would be 5, 22, 5. All right, so A being 1 is less than C, which is it's going to iterate through 4 times, or 4 times, yes. It's going to say A is A plus 1, so 1 plus 1 is 2. Then B, which is 2, plus C is 7. So then it goes 2 plus 1 is 3. 7 plus 5 is 12. Comes back 4. 12 plus 5, 17. And then comes back again 5. 17 plus 5, 22. And then we print it out 5, 22, and C never changes. So it'll always be 5. Does that make sense? All right, so the next one, 4, 6, and 7. So let's go ahead and do these. Let's say B, E, and F is going to be 4, 6, and 7. And then it's going to be D is greater than F, is greater than F. Let's say D plus 1. I think it was E equals E minus 1. I believe. Hold on 1 second. It was D plus 1, E minus 1. Then it wants us to print out D, E, and F. And so that will be 4, 6, and 7. 4, 6, and 7 would be B. So C, we're going to use G and H. We're not going to be using this one. G and H. So it's going to be no, for B would actually be 4, 6, and 7. And then for C, we're taking G and H. When G is less than H, increment G plus 1. So G is 4. When G is greater than H, it's going to equal 6. So that would actually print out 6 and 6. So for the next one, we're using J, K, N, 9, 5, and 2. It's going to say when or while J is less than K, M is going to equal 6. M equals 6, and while M is less than N, give me 1 second. M equals M plus 1. I'm just going to print out goodbye. I mistyped something. Hold on one second. There you go. And it would be 9 times. 9 times. The next one, I'm going to move the book over here where I can see it. So yeah, it does say goodbye 9 times. Then I'm going to write E and F. I'm going to show you E right here as I type it. So J is going to be 2, K is going to be 5, M is going to be 6, N is going to be 9 the same way. But this time we're taking that out. M is going to be N again. And it's going to say hello. And it's going to say hello 3 times. And the last one for F is going to be P is equal to 2. Q is going to be equal to 4. Or P is less than Q. We want it to say adios. And then R is going to equal 1. We haven't specified R. R. So while R is less than Q, we're going to say R and R. Adios. And then we're going to come back out and say P is equal to B. It should be 8 times. 1, 2, 3, 4, 5, 6, 7, 8 times. It is. All right, so that's the first, that's chapter 5, number 1. And then for chapter 6, number 1, pull this back up. It's on page 267. Design the logic for a program that allows a user to enter 12 numbers and then display them in reverse order. Okay, so what would your solution be? See, here's our solution. I wrote this a little while ago. Let's see. So you start your index, you set your size, yep. Okay, you didn't use, yep, okay. You get your numbers. That'll actually work. James, that works. Excellent job. I'll show you that one too. If you don't mind, James, I'm going to show this one also. This is right here. All right, so that's the assignment for this week. I'll go ahead and close this out. And I'm going to close that out. He's probably not laughing at you. Okay. Okay, so let's go ahead and preview. I'll give you a second to go ahead and load yours up. All right, so the first question, the loop that frequently appears in a program's main line logic is what? The loop that frequently appears in a program's main line logic is going to be works correctly based on the same logic as other loops. So it will be B, yes. Number 2, the statement executed within a loop are known collectively as the what? It's actually going to be the loop body. Number 3, adding 1 to a variable is called what? It. Adding 1 to a variable is called what? You're right, it is D. It's called incrementing. Number 4, which of the following is an indefinite loop, or a runaway loop, so to speak. A loop that executes exactly 10 times, a loop that follows a prompt that the user asks, or both of the above. You're both right, it's none of the above. Number 5, when two loops are nested, the loop that is contained by the other is the what loop. Captive. It's actually called the inner loop. It's called the inner loop. Most programmers use a for loop when they know exact number of times a loop will have to repeat itself. You're right, James. When they know the exact length of time that the loop will have to repeat itself. Number 7, typically the value added to a counter variable is you're correct, it is 1. All right. After an accumulator or counter variable is displayed at the end of the program, it is best to delete the variable, reset it, subtract it by 1, or none of the above. It is none of the above. Number 9, overriding a user's entered value by setting it to a predetermined value is known as what? You're both correct. It is forcing. You're forcing that variable. Variables might hold incorrect values even when they are what? You are right, James. It is D, all of the above. They can have the correct data type, they can have the required range, and they can be hard-coded essentially rather than input by a user. So number 11. Each variable is an array. In an array, must have the same blank as the others. Must have the same blank as the others. It's going to be the data type. All right, number 12. The subscripts of an array are always what? The subscripts. The 0 to 9 is what we call subscripts. You're right. Integers. They are integers. Number 13. Suppose you want to write a program that inputs customer data and displays a summary of the number of customers who owe more than 1,000 each in each of 12 sales regions. Customer data variables include the name, the zip code, the balance due, and the region number. At some point during the record processing or record processing, you would add 1 to an array element. whose subscript would be represented by what? If we're changing to 12 regions, that's the key word there, the regions. It would be, you are right, Aaron, it would be, and James, it would be region number. Number 14. A program contains a 7-element array that holds the names of the days of the week. At the start of the program, you display the day names using subscripts named day num. You display the same array values again at the end of the program, where you blank as subscripts to the array. You can use day num, or you can also use another variable. So it would actually be B, right? You can either output it to a whole different variable or to the same one. So filling an array with values during a program's execution is known as blank the array. You're right, it is populating the array. Number 16. A blank is a variable that you set to indicate whether some event has occurred. It would be a flag. You would set a flag to make sure that event has occurred. Once it occurs, you set the flag to true. Kind of like checkpoints or milestones for college. I've hit 20 hours. I've hit 30 hours. I'm considered a sophomore, a junior, a senior. Number 17. In most modern programming languages, the highest subscript you should use with a 10-element array is what? Keyword there is going to be the most modern programming languages. It would be 9. You start from 0 and go all the way to 9. Because in a 10-element array, it's 1 to 10 or 0 to 9. All right, number 18. Each element in a 5-element array can hold blank values. Each element in a 5-element array can hold blank values. It would be 1. Each value can only be held by one element. So number 19. When you use a subscript value that is negative or higher than the number of elements in an array, what will happen? And remember, he talked about this in the video. Hackers love to use it all the time. Essentially, what will happen is, depending on the programming language, most high-level languages, is the resulting action depends on that language. If it's a low-level language like C or assembly language, so it would be B. You would have to account for those particular issues. But in Java, C++, Visual Basics, you do not. They're already inherent to the compiler or the interpreter. And the last one, you can access every element of an array using a blank. You can access every element using a blank. It's going to be both. You can use a while loop or a for loop. Either one will work. All right, so let's go back. First one is B. Second one is A. 3 is D. 4 is D. 5 is C. 6 is D. 7 is B. 8 is D. 9 is A. 10 is D. 11 is A. 12 is A. 13 is D. 14 is B. 15 is C. 16 is D. 17 is B. 18 is A. 19 is D. And 20 is C. All right. Aaron or James, if you don't have any questions on any of this, I do want to mention that I have an abbreviated schedule next week. I'm going to have this lecture around 12 p.m. Mountain Time. But I will still hold my office hours. So if anyone does have any questions or concerns, I'll still have my office hours for you also. Yes, 12 Mountain Time next week. Aaron, you said your test did a weird misclick. What do you mean? You clicked one and it actually clicked the other one for you? Uh-oh. Well, you do get 2 chances to take it. All right, so if you don't have any questions or concerns, again, please don't forget your assignment and your assessment are due by Saturday. Your initial discussion post, which James, I saw yours earlier today, is due by Wednesday at 11:59. And then your 2 other posts are due by Saturday at 11:59. If I don't talk to any of you before the office hours or before next week, please have a great week, a great weekend, stay safe, and I'll talk to you later. All right? And have a good night.